Okay, so this video we will continue the beginner's guide to SDL2 in COBOL. This is the 6th video. So if you are just starting with this video, you will need to go to github.com, programming rainbow, beginner's guide to SDL2 in COBOL. You'll need to clone this repository, and since this is the 6th video, we're going to be continuing with the work that we did in the 5th video. So if you're just joining this one, you'll need to grab the source file, the main.cbl file inside of video 5, and move it into the source folder. And that's where we'll be working today. So we have opened a window, we have closed a window, we have drawn a background, we have changed the color of the background. So now let's generate some font, some true type font, and then we'll move it around the screen. And before I get started on that, I just want to, I did have a look at it, and the SDL init everything, this macro is actually an unsigned int, and so is this SDL window pause center. So this is not going to affect anything for you right now, but just to be more correct, I'm going to switch these to unsigned ints. Just these two, not the image init PNG that actually uses an enum. That is just an int. So I think down here, there's an unsigned int right here. I'm just going to grab this one. And I've already changed this in the GitHub. But if you're following along with the source code, I just want to tell you what I've changed. So it's going to be just the SDL one up here. I'm just going to change that to an unsigned int. And this SDL window pause centered, I'm going to change that. And again, it's not affecting anything because both of these fit into an int or an unsigned int. But just to be as correct as I can possibly be, I'm changing those two. Okay, so we will be working with a new module today. It will be the SDL TTF, or the SDL underscore TTF module. So it's an add-on to SDL2, like the image module was. And so this is the function that is going to initialize the module. It's just TTF init. And it's returning 0 on success, so we can test if it failed or not. And it's not receiving any inputs. And then to shut it down, we have TTF quit. And this one is not returning anything, and it's not receiving any input. So let's start by initializing TTF and then shutting it down. So we don't need any flags for TTF, so I'm not going to be creating any flags. So we can go straight down into the initialize section. And I'm going to put all the initialized stuff I'm putting up here. So we've initialized SDL, we've initialized the image module. So I'm going to put it right below here. And just to be quick, I'm just going to kind of copy this code right here and modify it. Or actually this top one, since we're looking for 0 on the success and anything else is a failure. So I'm going to grab this right here. I'm going to copy that code and I'm going to move down below the check of the image module. And I'm going to paste it there. And this one is image. And we are not receiving any flags for this one. So there's no flags. We are capturing the return. And then we are checking the return. And the error message should be SDL TTF. Just like we did with the image one. Okay, so that is us initializing the SDL TTF module. I don't know why I just put image in it here. It is, sorry, TTF. And I did put TTF there. So we are correct on that one. So before we test this out, I'm going to go down to the cleanup, to our clean and exit down here. And exactly the way that I'm, since it's the last thing that I've initialized, it's the first thing of the modules that I want to shut down. So here's SDL quit, here's image quit above that. Since it was the last thing it's a last in, first out. So since it's the last thing I initialized, it's the first thing I'm going to uninitialize, or I'm going to shut down. So again, I'm just going to grab this code because it's very similar. So I don't have to fight with the indentation and capitalize and everything. Okay, and this one is called TTF quit. Okay, so that is shutting it down. We are capturing the return, but we're not testing it. And before we go any further, I want to change the name of this. So instead of colors and icon, we will call it, what shall we call it? Something like moving text. Yeah, we'll call it moving text. And for the actual SDL screen title, when the window title, we'll call it moving text as well. And not forgetting to change the very bottom one. It needs to match the top one down here. Okay, so before we code any further, let's just make sure that no mistakes have been made so far with the opening of the TTF module and the shutting down of the TTF module. So I'm gonna do a make rebuild. That's gonna recompile it and run. And we won't see anything different here because we haven't created any text yet, but I just want to see that the program is opening up and shutting down correctly without errors. And there's an error, so I have made a mistake. Well, it's in initialize and we have an unexpected returning. So let's go check it out. We did our SDL init, our image init, and we got our TTF init. And this is returning return value. That should just be fine. It says it's at 104. I know it's not returning a value, but I'd like to capture anyway, even if it's void. Oh, I have this using. I don't need the using there because I'm not passing anything in. I believe that's the issue. Okay, yep, that was it. So we didn't, since I copied the code above, we were passing in a parameter, and we're not passing anything into this one because this one doesn't take any flags. Okay, so now we have that module up and running, and we're shutting it down. Now we need to talk about what we need to create a font. Well, to create text. So we need three things. We need a font size, we need a font color, and we need to create an actual font. So the font color in SDL is just a struct that has 4 uint8s, 4 1-byte unsigned integers that are 0 to 255. And that is how we hold a color. So let's do that first. We're going to create this color up in the working storage section. And it's going to look very much like what we did with the background color, even though we didn't use, when we were changing the background in the last video, we used the values of the colors separately, but this time we're going to actually use the struct, the color struct as it was intended in SDL. And we need a font size, and for this I'm just going to use size 80. So let me just show that real quick before we get into it. So we are going to create this font, and we need the file, but we also need a font size that we're going to pass in, and it's a point size. It's not a pixel size, but it's going to be size 80. So I'm going to create these two first before we start working on the font. I'm going to create the variable that will hold the font size and also the color struct. So we need to go up to I'm going to close this down here. I'm going to close the bright panel too. We don't need it. So we're going to do a very similar thing to this right here, even though, like I said, we didn't use it originally as a struct in the last video. We are going to create another one. So I'm going to copy this. And this one we will be using as an intended color. I'm going to give it another line. So we'll call this one, we could call it font color or text color. I'm gonna call it font color. And above it, I'm gonna put the font size that we need. And this is going to be a binary int. So we're going to say usage binary int, and the value will be 80. Okay, so we have our font size. Here's our font color. I'm going to change these values here as well to font color RGB. Yeah. Oops, not capitalized. And I'm going to put the value of these at 255 because I want the font to be white. But if you'd like to use a different color, you can. So notice that this is the red value, the green value, the blue. So if you wanted red, you could just put 25500, green 0, 255 0, so and so, and you can mix the colors. If I just turn them all on, we're going to get white. And if you turn them all off, you get black. You won't be able to see the text because the background is black, unless we change the color of the background. So each of these I'm going to set to 255. Okay, so we have the font size here. We have the font color, which is containing the red, green, blue, and alpha channels. Everything is turned to 255. That's the maximum value that you can put here. Okay, since we have that, we will also need, well, we'll come back to that. I'm going to redefine. So to get this to be used, kind of like we did up, where is it? Up here. To get this to be seen as a struct, kind of the way that C would see a struct, we need to redefine this. So I'm going to right away, I don't know a very good way of explaining this, but we're going to take this COBOL type of data structure, and we need to use it better as what C can see it as, more of a structure. So we're going to redefine this as a font color struct, and we're basically just turning it into a binary int, because if you think about this, this is a 1 byte, 2 byte, 3 byte, 4 bytes. Well, an int is just 4 bytes. So we're going to basically turn this into an int, and C will see it as what it wants to see it as. If it thinks it's receiving a struct, it's just going to see it as this byte structure. It's going to work out. It may not make sense the way I'm explaining it, but it'll work for us. So I'm going to do a 0, 1. I'm making a new value here. I'm going to call it font color struct. And we're using redefine. Redefine. Oh, sorry, font color. Wait, this up here needs to be, this up here is the struct. And the font color will be, so this is kind of our imaginary struct, and this is going to be the value that we're going to be able to pass around into C. So it redefines, so font color, this needs to be color, not color struct, redefines font color struct above. And we're going to say usage is binary int unsigned. And this will have to be, we'll just wrap the usage around. Got the caps lock on. Okay. Okay, so we are redefining font color struct. We're creating font color. We're redefining font color struct as font color. It's kind of like, I believe this is like a pointer to this thing, but it's just being seen as an unsigned binary int. So we have a color now. We have a size. We will be talking about rectangles very soon. maybe after we kind of load up something first. We also, to be able to create a font, we're going to need a pointer for the font. So I'm going to create a font pointer where all our pointers are, right here. I could have just, I'm just going to copy this one because the indenting gets kind of annoying after a while. I'll call this font. I'll just call it font pointer. Okay. Now we can go look at our function that is going to be making font. So we've created this color struct, which is just 4 values. And we have already created the size. So let's talk about creating the font. We have a TTF open font. This is going to return a heap allocated TTF font struct on the heap. And it's just receiving the file name of where this font is and the size that we have already created that value for. And when we're done with this, the way we close it is TTF close font. It's returning nothing, and it's just taking in a pointer to the font. Okay, so let's do this one right here, TTF open font. And this is going to be in the load media section. SDL initialize, and where is load media right here? And I should have put an exit at the end of this load media. So that is the function that we're calling. And we're going to be using there we go. We're using by reference. And we need the actual font. So let me show it to you here. Oh, the tab button. It's getting me every time. Okay. So the font that we're going to be used is in the fonts folder, and it is Free Sans Bold TTF. That's a true type font. Okay, that's the font that we're going to be loading. I was trying to get the sidebar to open over and over again. I had the caps. I don't normally have the caps lock on. It was really messing me up there. So that's the name, and we're going to have to send that in by reference, and it's going to be a C style string. So by reference, and this is going to be the Z in the beginning for that C style string, and the location is fonts, and it is free sans bold.ttf. So that's our actual font that we're going to be loading in, and we need to also to give it the size of the font, and this is by value, and that is the variable we made it above called font size. And then we will be returning the font pointer. And we'll end that call. Okay, so that is us opening a font. And to close the font, it's TTF close font, and it's just returning the actual font. So that will be in the cleanup, where we clean up pointers. So here we're closing down the TTF module, but I'm going to put where we're cleaning up resources, I'm going to put it on the top here. This is not indented correctly. So this is TTF close font using. Yeah, that is using. So we need the pointer. So that's by value. And we will be capturing the return. We're not testing it, we're just capturing it. Okay, so that is the end. So that's us closing the font. So we've opened a font, closed the font. Let's test the code real quick before we can actually draw something. Well, we have to make a text first, but I just want to make sure that I haven't made any mistakes. Okay, so we've opened a font, we've closed the font. Now the way that we're going to actually make something that we can see, we're going to make text that's on a font surface. So we can't make it directly to a texture. We have to make it as a surface, and then we're going to convert the texture or the surface to a texture. So first we need to make a surface. So TTF render text blend. We're using blend, so we get we don't get any aliasing or we don't get any blockiness around the curves of the letter. So it kind of smoothly blends it. So TTF render text blend. It's going to take the font that we've created. It's going to take the text that we want to create on this surface, and it's going to take the color. And it's going to return a heap allocated SDL surface. Okay? And we're going to just test that return for null to see if it failed or not. So let's build that first. So we will need a surface. So I'm going to close this sidebar. So in the pointers here, I'm just going to copy this one and make a surface one. And we will call this text surface. Or we can just call it surface. It doesn't really matter. Text surface, it's set to null by default because we have that value there. Okay, so we have that. We need to actually, let me grab the function name again. So remember, we're by value, we're going to send in a pointer to the font. By reference, we're going to send in text, and then by value that we're sending in the color. That's kind of that strange structure that we made for the color. Okay, so this is going to be down into load media again, right here. And we will just call that function. Okay, so we need what by value, we need the pointer to the font. And then by reference, we need a C style string. So we're going to have the Z. And then I believe we want this to say COBOL. We want COBOL to be, the word COBOL to be bouncing around the screen. Okay. And then we are also sending in by value that color that we made. And that's going to be white for this. Font color. And then we're returning our text surface. Okay, and now we need to talk about cleaning up this surface. So we've done it before. I believe we've cleaned it. We did clean up a surface before. It was right here. We cleaned up the surface for the surface icon. So I'm going to grab this, and it's going to be down here in the cleanup right here. And we could have cleaned it up right away too. Yeah, we can free the surface right after we convert the surface to a texture. So we don't need it here in the cleanup section because we don't need to hold on to the surface. We're going to clean it right away. And we should have tested this surface as well. We didn't test failure on either one of these. We need to test failure. So I'm gonna put that the cleanup there just to hold it there for a minute. Well, it'll be here in the end, but I want to get back to the cleanup before I forget about it. So we got free surface, and this one is the text surface. That's where we're cleaning that up. Okay, so we need to think about these two, this open font and the render text. This one we're checking the pointer on both of these. Okay, so here's how we check a pointer. So we're checking the pointer for the font. Okay, for this one we have error opening font. Error opening font. And then we need another check on this the surface that we just created right here to see that it was actually created. And this one is a text surface. Text surface error creating a text surface. Error creating text surface. So there we're checking if our font got loaded, and then we're checking to see if our surface got created. And here we're cleaning up the surface. So let's just make sure that runs, and then we need to convert our surface to a texture, and we also need a rectangle before we can display it. So those two things, but let's just make sure that our code is running correctly. Okay, that looks good. So we have created we haven't got to see it yet, but we've created this surface with this text that we put on it that says COBOL. And we are freeing the surface. But we need to do this create texture from surface. So we're going to convert the texture that we have to a surface. And this function takes in a pointer to the render and then a pointer to that surface. But we have to think about something else. Before, when we drew the background, we drew we got the entire surface of the background. We used null. And then when we displayed it on the render, we displayed it on the entire render. This time we actually want to use a rectangle. So that because the COBOL is not gonna, well, let's just show it without the rectangle first, and then we'll create the rectangle for it. So we're gonna see this text stretched kind of ugly. It'll be oversized and pixelated because it's not the intended size that we created the text, but then we're gonna use a rectangle after that, and it's gonna fix it up. So this first function that's returning a texture, we already have seen what textures are. And so we're just going to use this function to convert our surface to a texture. And we'll put that right above where we're freeing the surface. So right here we have our surface, and then right here we're freeing it. So in between them, we'll do the call. And we'll say using by value, and we need the pointer to the render. The SDL render. But we also need by value the surface. And that is the text surface. And we're going to be returning a pointer to a texture we haven't created yet. So we'll call it text image. And then we got to go up and create it. returning text image. Okay, so this is going to work, but we haven't created this yet, so we need to go create it. And we also need to free this texture. So let's first create this pointer. I'm just going to grab this one here. And this one's called text image. Okay, so we got the pointer for that. Now we already know how to release and we haven't tested the surface either that we just, the texture that we just created. We haven't tested it. So we need to test it the same way that we test all of the other pointers for null. Grab this one here. And I'm actually going to free this surface no matter what first before I even test it, because if the surface was created and we're good, and we go to create the texture, but the texture doesn't get created, we shut down, and this never gets called. But however, I want this cleaned up no matter what. So if the surface was created, we're still running. We go to convert it to a texture. We don't care if that worked or not. We free the surface right away, and then we test if the texture was created. Because I want the surface freed no matter what. No matter if the texture was created or not, the surface needs to go away. This could possibly shut down the program, so I want this to run first. So here we have, is it text image? Text image, and we'll say error creating texture from surface. Error creating texture from surface. Okay, so that's testing it, and then we need to free it down here in the cleanup, because this is something we are holding on to while the game's running. And the way we free a texture is this one right here. So again, it's like first in, first out for the, or last in, first out for the resources. So we're destroying a texture, and it's called text image. Okay, now we can display this now because we already know how to display things. But like I said, it's going to be displayed wonky because we don't have a rectangle yet. So I'm going to use this render copy exactly like the background, and I'm just going to put it below the background one. So it's going to be drawn on top of the background. Okay, but we're not using the background image. We're using this text image. So it's going to look messed up. Now keep in mind that if I wanted the text to be full screen, I could make it look really nice and smooth because I would use a much larger number. But because I used size 80 and then that 80 is being stretched, it looks pixelated. And that's not the fault of the font. That's the fault that I actually created a small image and then stretched it. If I use like point size 300, I would get a really nice looking large font. So we're going to see an ugly font because it's not that big and it's being stretched. Okay, so I'm just going to remove this extra line, and hopefully this code will run. And it didn't. Okay, so what do we got? Source text after program area. What? First. Well, it's at 221. So let's go see what happened at 221. 221. Oh, this message is too long. I think I just exceeded the bounds. Yes, I did. And there's the ugly COBOL. Like I said, it's supposed to look ugly right now because we were creating a text that should only be this large. If I created a text this big, it wouldn't have these pixelizations. But again, we used a null for the source and a null for the destination rect, so it's stretched it to the entire size. So what we're going to do now is actually create a rectangle and then use that rectangle to display it properly. Okay, so the rectangle is very much like the color. I don't think I brought up a... No, I didn't bring up a page for the rectangle, but all the rectangle is it's 4 ints. It's just 4 standard integers in a struct. So just like the color is 4 unsigned 1 byte, u into 8s, a rect is 4 just standard binary ints. And we are going to create some other values too, because we want it to move around. So we're going to create a velocity and an x velocity and a y velocity and the rect. So we'll just do that real quick. I'll put it here. So it's going to look very much like this right here, but I'm going to create these other, the velocity stuff first. So I'm going to make 3 velocities. The reason for this is I don't want to use a magic numbers in my code. So I have an x velocity, but it may change the opposite. It's going to be positive and it's going to change to negative. And I have a y velocity and it's going to do the same. And they're all the same number, but sometimes it's going to be negative, sometimes it's going to be positive. So what I'm going to do is I'm going to just hold the number as velocity, and then I'm going to hold on to an x velocity that I may flip to negative based on the normal velocity number. So I don't need to put other magic numbers in my code later. So we'll call this text vel for just the standard one that's holding what the velocity could be, whether it's positive or negative. I'm going to say usage, binary int, value, and this one is going to be 3. Okay, I'm just going to duplicate this because the other 2 are going to look exactly like it. Okay, and this one is going to be xvel. Oops, not capital X though. We'll just use lowercase. And this will be yvel, and they're all 3. Okay, now we're going to create this texture or this rect, this SDL rect. So it's going to be 0, 1. We're not. I think we're passing this in by reference, aren't we? Okay, that's fine. So text rect, and then I'm going to have 05 text rect, and this is going to be the x. We'll have usage, binary int, value. I'm just setting it at 200. Doesn't really matter. We could just set it to 0. That's just the starting point for x. I'm going to duplicate this because the other 4 are going to look exactly like this with just different letters. Okay, so we're going to have an x, y, and a w and an h for width and height. And these are capital, they should not be. Okay, so that is going to be our rect, and it's just all zeroed out right now. We're going to populate this rect. So we're going to do an SDL query texture. So I don't have that, but there's a, let me pull it up. And this is going to take in the texture. Okay, and it can have a font and it can have an access, but both of those are going to be set to null. And what we care about is the width and the height. We want those to be populated. We want our rect's width and height to be populated. So we're going to use this function, and it could fail. So we're going to check the return on this, and it's 0 on success. And we're going to use this to populate our width and our height of our rectangle. So SDL query texture. And we need to do this in the same section that we have our, where is it? Where we're, not the draw section, where we're the load media. We got load media, we're checking that our texture exists. and then we're going to query this texture. I'm going to say using, get some space there. And we're going to do by value. We're passing in the texture itself, which is text image. And then we're going by reference null twice because we don't care about those other two parameters. Now, this is what we're trying to populate. We're trying to populate our text rect width. So we'll say by reference. And that's text rect W. And then by reference, the height. Text rect H. And now we have our return. And we will test this return value because this is something that can fail, and we actually need that rectangle. Okay, so we're going to be checking if it's 0. So I believe I have one up here that is checking for 0. Right here, this looks good. I'm going to grab this guy. And our return value not equals 0, we'll say querying texture. Okay, so that is going to populate our rect. Now, to actually view our text with this rect now, we're going to say instead of by reference null in our draw all, so we have, this is our source rectangle right here, and we do want our entire source of our image, which is that text image. We want to see all of that, but we only want it to be displayed on the renderer that the size it is. So imagine our COBOL on this text is say 100 by 200, or say 200 width wide by 100 height, right? So if we say null, we're going to get 200 wide by 100 tall. But if we say null on the renderer, it's going to stretch it to 800 by 600. So what we want to do is we just populated our width and our height. So our width is now 200 for our rectangle, and our height is now 100 for our rectangle in this imaginary scenario. So we have the rect size. So what we can do is we can say, hey, display that. Even though we're grabbing the whole source, we actually know the size of it, and we want it to just be displayed as 200 wide by 100 tall. And then the source of this, where it's going to show up on the screen, is going to be based on the very top left-hand corner. That is called the origin of the image. And that origin of the image is set at 0, 0 because that's what we set our rect at. And the origin of the screen, 0, 0, is the top left of the screen. So this text is going to be displayed in the top left of the screen. So I'm going to change this. This is the source. I want the entire source, so that's still null. But this is the destination rect, what is going to be drawn on the render, and I'm going to change this now to our rectangle. So it's going to be text rect. And now we should see this being displayed as like correct size in the top left-hand corner based on this 80 size font that I used. Okay, yeah, there it is. So the origin of this image here is the top left-hand corner right here. Okay, and I could have made it bigger. I could make it, instead of 80, 300, 400, and it would just keep bigger and bigger, and it would look smooth. It would look nice. But 80 is good enough. Okay, so what if we want to move this around? Well, to move something around, we just move around the X and Y of our destination rect. If we just manipulate that number, we can move our text. So we're going to make a new procedure called update text. Okay, I'm going to be kind of flying through this one. It's going to be right after our change color procedure, right here. And this will be called update text. Okay, and I'm going to increment my text rect x by my text x velocity. So whatever my x is, I'm going to be adding the x velocity to it every frame. And the same with the y. Whatever the y is, I'm going to add the x y velocity. So let's just start writing that. So I'm going to say add text x vel to text rect x, and then this is end add. So I've added it, but I need to check to see if it's gone outside of the screen. Okay, so what I'm going to do is I'm going to say if the image is moving, I don't care which way the image is moving, but I'm going to say if it has gone this way, where the x has gone below the screen size number, which would be below 0, I need x velocity to start moving in a positive direction. I need the image to start going this way. And when it's this way, if I take the x and I add the width to it, and if I find that that has exceeded the width of the screen, I need x velocity to be actually a negative number. And I'm going to do the exact same with the y. So I'm not even going to check what direction it's going to move. I'm just going to say if it's gone beyond that thing, I'm setting the velocity to the version that makes it go the opposite direction. So we got if text x vel, and we'll say is less than 0, then I'm not even going to check the direction. If x, so I don't need to do it this complicated. I'm going to just check, like I said, if it's the bounds has. So I'm going to say text rect x. I was checking direction, but it's unnecessary. So if the x is less than 0, I'm going to set it. So set. I just need to change the direction. So xvel 2, and this one, if we're going in a negative direction this way, we wouldn't change it to a positive number. So I'm just going to change text x velocity. I'm assuming it's a -3 right now. I'm going to just change it to whatever text velocity is, which is +3. Okay, and then we're going to end if on that. And we need to do the other side if we were going the other way. Now now it's if it's penetrated 0 and it's gone negative, I could have set it to negative and I could have checked direction. I don't actually need to do any of that stuff. I can just do this and that'll totally work. So this is what I'm going to do for the other side. If text rect x plus text rect w, so if the x plus the w, that gives me the right side of the image, is greater than that's fine, I just tab it in. Window width. So if it's greater than the window width, now we have to set x velocity to be the negative version, and we can't just set it, we need to compute it because we need the negative version of of the velocity. So we're going to say -1 times text velocity to get the negative version of it. So if this is happening, we're going to compute on this one. This is a little bit different because we're not just setting, we need to compute it. Compute text xval equals -1 times text val, and then we can end that compute. There's no period on that. So we have to compute it because basically I want the x velocity to be the negative version of velocity. I want it to go the other way, so I have to do this -1 times that, and that's in a compute. And now we can end the if. Okay, so that should work for the x. Let's just check that, and then we can do the y. So, and the y will be almost the exact same. But we need to call this, we need to perform this. What's it called again? The procedure. So it's going to be in the update. So here we're checking. Oh, it's going to be in our main loop. Sorry. Where's our main loop? Main procedure. Here's our loop. We're performing check inputs, and then we're drawing. So before we draw, we need to update things. So we'll perform here. Spelling wrong. Oh, come on. So this is text update. So we're performing text update, and hopefully we should see the text moving left and right on the screen if I haven't made any major mistakes. And I did. So it looks like we're looking at in the update, unexpected identifier and 329. Oh, I don't think I put a period here on this guy or this guy. And I should just put an end or an exit just for visual. Okay. And now we got something else going on. Text update is not defined. What did I call this? I called it update text. So we need to go back to the main procedure. Okay. Okay, it should be bouncing back and forth, hopefully. Yes, there we go. Okay, so I'm going to do the exact same thing, but for the y. So we'll go down to the update text. Here it is. And it's going to be very much the same deal. So I'm going to copy this. There. And it's going to be y velocity. And we're changing y. Okay. And then the y is greater. And this is y. And then we're doing width. We're doing y plus height. And we're checking window height. And then this is y as well. That all should be good. So hopefully we should be bouncing around the screen now. Okay. Looks good. That's why I had it set at 200, so it wouldn't hit the exact corner. We could change that to up here where we're defining our rectangle. We can have X starting at 200. Okay. And that gives us bouncing a little bit better instead of going directly to the corner. And we're called moving text. That looks good. And I hope you enjoyed this one, and thanks for watching. Bye.